These are your instructions. In general, you just need to follow the PowerPoint. There are instructions for you in the yellow boxes on each slide. Please make sure the sound is turned up on your device so you can hear the narration. And remember, if a slide asks for homework, don't forget to send it via Show My Homework. If a slide asks for Educate to be completed, don't forget to do it by the date that's given on the slide. At the end of this lesson, you should be able to carry out the required practical on density to describe how we can calculate the density of regular and irregular objects. This is our starter activity. Can you remember what two things you need to know in order to calculate the density of an object? And can you remember the formula for calculating density? Stop the recording here while you think. You should have remembered that density is mass per unit volume. So in order to work out density, you need to know the mass of an object and the volume of an object, and then use the formula density equals mass divided by volume. In this lesson, we're going to use Focus e-learning to calculate the density of regular and irregular objects. Follow the link given on this page, which is also given on Show My Homework. And if you need to log in, if it asks you to log in, use the login details given here. So once you're on the Focus e-learning page, click on Physics Required Practicals. Click on AQA, which is our exam board. Click on Density, which is the practical we're going to be doing. And before you go any further, draw yourself a results table like this in your book. As you can see down the left-hand side, we're going to be working out the density of all of these 5 different materials. 4 of them are going to be regular objects, so we're going to measure the length times the width times the breadth. We're going to calculate the mass of each using a mass balance, and then this column is for calculating the volume of your solid objects. And then we're going to use the formula density equals mass divided by volume to give us our final result of density for all of these materials. Draw the table now. On Focus e-learning, we're going to start by working with a regular block. We're going to use a variety of materials. Start with aluminium. Use the ruler to measure the lengths of all 3 sides. Every time you click on the block, it will change it to a different side so you can measure it. Please be careful when you're using the ruler. If you look at this measurement here, the block against the ruler only goes from 2 to 8 centimeters. So this side is only 6 centimeters long. Be careful how you do your measurements. Record your measurements in a table like this. Next, if you click on Weigh Block, a mass balance appears and you can work out the mass of your block. Record the mass of the block in your table. You're going to repeat this process for the other 3 materials. By the end of the process, you should have the length times the width times the depth for all 4 materials, and also the mass of the block of all 4 materials. For the next part of the practical, we're going to look at an irregular object, in this case a rock. This is a method for working out the volume of the rock that we've seen before. Drop the rock in the water and work out how much liquid is displaced to give you the volume here on the measuring cylinder. Record that volume here in your table. If you click on Weigh the Rock, a mass balance appears and you can measure the mass of your rock. Record the mass here in your table. Now it's time to do some calculations. For each of your blocks, you can work out the volume by multiplying the length times the breadth times the depth. And then you can also work out the density by using your formula density equals mass divided by volume. Remember, for the rock, You have the mass from the mass balance, but the volume is taken from the volume of liquid displaced when you drop the rock in the Eureka can. And then you can use the same formula, density equals mass divided by volume. Density is a required practical, so we need to know all aspects of it. If we were in school, we would write this onto a placemat. But as we are not at school at the moment, let's write it into our books just as if we were doing it on a placemat, and then we can transfer the information later. So start with a hypothesis. What do you think our experiment will show us? Will different materials have different densities, and why? 2. What are our variables? What is the independent variable that you are changing each time? What is the dependent, the one that changes as a result? And what is a control variable? Something that we're keeping the same each time we do the experiment to ensure we are carrying out a fair test. 3. What are the risks? 4. What method did you use? You don't need a great deal of detail, just put in bullet points. 5. Diagrams. You need to draw a diagram for a regular object and one for the irregular object, showing the experiment that you carried out. Your result is the data in your table, and your conclusion is what does your data tell you. For your homework, you need to send me by next Monday, the 11th of May, 1. A picture of your completed results table with the densities of those materials all calculated. And 2. A picture of your written work from hypothesis to conclusion. Send this to me using Show My Homework.